Hi guys, I hope that you had some fun with the recipe project. Just as a way to look at scheduling and how you could actually help out, how making a schedule could actually help something happen faster. For example, cooking a meal. Um, we're ready to move on to the next kind of unit in finite math here, which does not involve any graphs. Right? We started with Euler circuits, Hamiltonian circuits, which was graph theory. We used graphs, digraphs, directed graphs to make schedules, and we did bin packing. And now we're going to spend a lot of time here looking at what's called social choice theory, which involves voting, which is kind of fun because it's an election year. And what this does is it presents a couple of different ways that you could think about electing someone or something, or just even picking what you want to eat for dinner if there's a group of people, but voting on something. And I think we're used to or tend to think about the only way to do it is, majority rule. But that really only works that's only really guaranteed to work if there are two candidates that you're voting for. And even then, it could be 50-50. So what this chapter looks at is, what if there's no majority attained? You understand majority is good because it means most of the people are satisfied with the results of an election. But if a majority can't be attained because there are more than two people or things you're voting on, how do you ensure that most people are satisfied with it? Okay. So I want to take you through a bunch of different methods. We're going to go very slowly through this, one at a time here. And I just you can read through this, of course, yourself. We just talked a little bit about with two candidates, and you see some technical jargon here in social choice theory, which is a branch of math, actually, that looks at elections with only two candidates. What's interesting is when there are more than two candidates, okay? Which a lot of times there are. So how do you determine how are those solved? Well, those are still solved only by looking at people's first choice. If there are two candidates, you really only have one choice. You like one, you don't like the other. If there are more than two candidates, you might rank them. Okay? And that's what these tables down here are looking at here. The rank of voters. We're looking at an election here where this is the number of people in it, or the percents of the people that voted this way, because I believe that adds up to 100%. And let's assume it's that. We see here that 31% of the people that voted liked candidate A for best, candidate B second best, and candidate C last. 22% of people that voted liked B best, C second, and A third. 20% of people ranked them this way, and 27% of people ranked the candidates this way. And so who wins the election when that happens? Well, there's a bunch of different ways we're going to look at for how you can answer that question. The easiest way to do it, which is not always the most satisfying either, is what's called plurality. Plurality only looks at the first choices. Just like majority rule only looks at the first choices, plurality only looks at the first choices. If you don't win by a majority, which is one more than half, you win by a plurality, which is just the most votes. So when we look at this particular voting structure here with candidates A, B, and C ranked in those three ways, and those are the percents of people that voted according to those preferences, right? Who wins this by a plurality? You have to look at just the first place votes here, right? So as far as first place votes go, candidate A received 31%. Candidate B received 22% plus 20% of first place votes from these two columns. These two columns are different in their second and third choices, but not the first choice. And candidate C received 27% of the vote. B wins. because 22 plus 20 is the biggest number on there, 42, right? So keep in mind, 42% of people are satisfied with the outcome of that plurality election, while the remaining people are not. More people are dissatisfied with the results than are satisfied with the results by first place. Okay. Plurality is the only one concerned where we're going to be looking at first place. I'll tell you why people are dissatisfied. Sometimes you'll hear the term if a third candidate or a third party candidate can be an election spoiler. And that's what happened in this case. Because if you look at this, a spoiler, the official term is a Condorcet winner. And what that looks at, this is the same chart below here that is above. So the drawback, it says, is the candidate is the Condorcet winner if he or she defeats every other candidate in a head-to-head elections but loses the overall election. So head-to-head means if it were only between two people and not between three, another person would have won. And this election, basically, there was a spoiler in this election because this has a Condorcet winner. When it says question in the following table, is there a Condorcet winner? If so, who? Let me show you how I answered that. A is actually the Condorcet winner here. More people preferred A higher overall than, well, when you look at preferences overall. What you do to answer this question, I'm going to show you right here. So start with, if the election had only been between A and B. In other words, in this chart, ignore all the C's. We're only looking now not at first, second, third, but whose ranks higher. So A gets this 31% because A was preferred over B by these people. This 22% goes to B because B was preferred over A. Ignore C completely. This 20% still goes to B because B was preferred over A. Now, these 27% of the people, this is interesting. C kind of spoiled the election because if it had, imagine C's not here. Who would these 27 people have voted for? They can't vote for C because he's not in the election. They would have voted for candidate A because A is higher than B. So that's why up here, right? I'm putting those 27 with candidate A because we're pretending C doesn't exist. So the 27 goes to A because they're ranked higher than B. So if it had only been an election between A and B, A would have won. What if B hadn't been in the election and it had been only A versus C? A still would have won because look, A is ranked higher than C in the 31 column. A is also ranked higher than C in the 20 column. 30 plus 21 is 49%. C was ranked higher than A in the 22, and C was ranked higher than A in the 27 column. They only would have gotten 49%. So A would have won again. A is the Condorcet winner because if it had only been an election between two and not three, A would have won both. It wouldn't have mattered if A had run against B or if A had run against C. A would have beat either B or C. But guess what? They didn't because they only looked at plurality and B won by plurality. So is there a Condorcet winner in this table? Yes, because A would have won if you'd only look at the preferences. Who's higher, A versus B? Look at the preferences. Who's higher, A versus C? And that's how it would win. Okay? So that's all that we're going to look at today. But I would like you on page 2 of this handout to try this question with this new ranked voting way and this question here with an actual election of how it turned out. And we'll go over the answers to those tomorrow. By the way, I did do on my table here B versus C2. B1 versus C, but that doesn't really matter because B won the overall election anyway. You're looking for someone that didn't win the overall election that could have won against the other two candidates. Okay? So it doesn't matter that B won here because B won by plurality. Who is a Condorcet winner exists if the non-plurality winner wins by that. Okay? Let me know if you have any questions about that. And again, try these two questions, the first two questions there on page 2 of the